What we're taking a look at here is our operations with functions. Make sure that we follow the guidelines that we have. So what we're learning is that the function f times the function g using the variable n. So we're just going to stack these up as multiplication using parentheses. So what we end up with is a distribution problem essentially. So we'll distribute our 4 into both the 4n into 3n and to the 5. Once we do that, 4n and 3n make 12n squared. And then the 4n times the 5 is 20n. This is stated as f times g using the variable n. On this example, we have subtraction. It's very important on this that we use parentheses when we are subtracting. We can get away with it if we forget it on addition, but if we forget it on subtraction, then we have a major issue. So we have the h of x function, h of a, excuse me, which is a squared plus 5, and we are going to subtract the g of x function. If I write it this way, I'm going to have a mistake, because the way I currently have it, all I'm subtracting is the a when I need to subtract both of these. And again, we have a distribution of a negative sign before we can combine the like terms. So we have a sign change happening to our a, making it negative, and a sign change happening to our 1, making it positive. The other two terms do not have anything happening to them at the moment. And then we will combine our like terms, a squared minus a, and we have 4 plus 1, which is 6. And again, this is stated as function h minus g using the variable a. So this one we have a scale happening as well. You can see we have twice the g function minus 4 times the f function. So we've got several distributions happening here. Let's just set it up. 2 times the g of x function. Well, the g of x function is x cubed plus 5x. And then we are going to subtract 4 times the f of x function. So this is what we end up with. So we have distributions on two binomials here. We'll distribute our 2 into our parentheses here. 2 times x cubed will be 2x cubed, and 2 times 5x will be 10x. So we have that. And then it's very important, again, we are not distributing 4, we are distributing negative 4. So the negative 4 will be multiplied times the 2x, and the negative 4 will be multiplied times the negative 2. So we end up with negative 8x plus 8. Negative times negative is positive. We again look for our like terms. The x cubed does not have 1, so we'll copy it down. The x's do have a common term. We have 10x minus 8x, which of course is 2x, positive. And then the 8 has no like terms, so we will just put our 8 down here. So our function, 2 times g minus 4 of function f of x, would equal this term. This question says find the inverse. Now, some will have you replace this with a y. One thing I've gotten a habit of doing is making an f on the other side. So what I'm going to do is I'm going to swap my variables. So where the f is, we're going to put the n. And where the f is, we're going to put, where the n is, we're going to put the f. So this is our setup for an inverse function. And now that we've done that, we need to solve for our f function. So we're going to slowly just unpile all this stuff off of our f. The first thing that has to go is the 2. That's the furthest thing from it. So we're going to get rid of a dividing by 2 by multiplying times 2. 2 times n, of course, is 2n. And we have now eliminated our denominator here. Now I should have stopped and looked because I see a division. I should be thinking about excluded values. But there were no variables in the denominator, so there are no excluded values. So we're okay. So we now subtract the 4 away from the f. This is going to leave us with 2n minus 4. So we have now isolated our f value. The way we denote a inverse function is f to the negative 1 power of, I almost put an x there, but we are using the variable n. So I need to use the variable n. So it's f to the negative 1 power of n. That's how we state inverse. So we've got a square root function, and both sides actually have square roots. So if we have any kind of even root, we have a potential for restrictions on the domain, excluded values, any number of things. So what I'm going to take is those radicands. In this case, that's 33n, minus 16. And I've got to make sure that that stays greater than 0. And I've also got to take the 2n minus 10 and make sure that that also stays greater than 0 or equal to, because I cannot take the even root of a negative number. 0 is okay, even numbers are not. So we'll go through this real quickly. We move our 16 to the other side and we divide. So we need our n value to be greater than or equal to, well, it goes in 5 even times with a remainder of 1. So we need to stay greater than 5 and 1/3. And on the other side, we add the 1, divide by 2. So the n needs to be greater than or equal to 1/2. So our more important thing is the, is the 1/2. It's got to satisfy these. So that's what we're looking for right there. I'm going to go ahead and erase the work for the restrictions and just leave the parts. We have those, but anytime you have an even root, you got to pay attention to things like that. So we've got those restrictions there. Now let's just go solve. Well, we want to isolate the radicals before we do any kind of powers. These are already isolated, so we're able to square both sides. Let me encourage you, if you do not have this square root on one side, you better put it in parentheses because everything is getting the power of 2. So if I have a binomial, you'll be doing the write it twice. But we don't really need parentheses here because the radical serves as a parentheses. But keep that in mind if you get stuck with a binomial. So these go away. And we end up with this. We subtract our 2n. And in the same line, I'm going to move the 16 the other way. So we have 3n minus 2n, which is n. And we have 10, negative 10 plus 16, which of course is 6. So we have a solution, potential solution at n equal to 6. And the reason I said potential solution, because remember we had some restrictions. The toughest restrictions is being greater than 5 and 1/3, which 6 is. So this answer works out for us. We're going to sketch this graph as well. Again, we can always put this in our graphing calculator and take a look, but what I want to do, just for practice sake, is look at the family of functions that we're sitting in, which is the square root of x. The square root function, remember, starts at the origin, because the square root of 0 is 0. Square root of 1 is 1. So the next number that has the square root equal to 2 would be 4, so 4, 2. And then I'm going to go off the graph and put the 9, 3. So this is the parent function. This is the parent function of a square root. Looks a little like that. And we have a transformation that says the x values are plus 2. Inside of the parentheses is a horizontal movement. Horizontal means left to right. And remember, anything that happens inside of a parentheses, and yes, this is a parentheses, that's one of those forms of grouping we talked about. Anything that happens inside of a parentheses has an inverse effect. So we are not moving right like a +2 feels like. We're going to actually move left 2 units. Every point is now going to be 2 units further to the left. So the one that was in the origin is now here. The one that's at 1, 1 is now here. The one that was at 4, 2 is now here. And the one that was at 9 is actually on the screen back here on this one. So this function, when graphed, don't even need a calculator for this, is going to look like that. The more points you have, the better your graph is going to look when you put it down on paper. So 59, we're going to be simplifying. Now remember our hierarchy. We've talked about what do you do with exponents. Remember, the first thing we knew was nothing, right? Nothing. Add. Multiply. And then powers. Those are the different things we said we knew. That's how we learned everything, right? And then powers. Remember, you do one level below. So in this case, we're doing powers. So what we do at the exponent is one level below, we multiply them. Power to a power, you multiply. If we were multiplying, the powers would add. If we were adding, the powers would do nothing. So we have a power, so we're going to multiply these exponents. So remember, this is essentially 9 over 1. So when we do a power and we multiply, we'll end up with 9 times 5, which is 45, and 3 times 1, which of course is 3. So this ends up being r to the 45 over 3 power. So when we have r to the 45 over 3, well, 45 over 3 actually reduces to 15. So that is the simplified form of that answer. Remember, roots, you divide the powers. And this technically is a root because we have a fractional exponent. So here's another solving. Anytime you get a solve and you get a fraction, just work on removing that fraction if you can get to it. And in this case, you can. Remember, what we've got to do in order to get rid of a fraction is always just multiply times its inverse. If you ever want to get rid of a fraction, we're all afraid of them. Well, if you want to get rid of a fraction, multiply times its inverse. Well, we can't just multiply because this is an exponent. So we need to give an exponent of the inverse. Well, that would be 6 over 7. So I'm going to go to the left side and give it an exponent of 6 over 7. So when we take 6 over 7 times 7 over 6, well, that's real easy work on the right side because this is just going to be 16n, excuse me. Now on the left side, excuse me, we take 128 to the 6/7 power. 128 to the 6/7 power is 64. I do want to take a side note in case we see this. I want to review this as well. But remember, if we were to write this in radical form, there's our radical. 128 is our base number. Remember, the denominator is the index, and the numerator is the power. We don't have to do this on this problem, but I just wanted to touch on it as a review. All right. So we end up with 64 equals 16x. So all we got to do to get rid of the 16 is to divide. We divide both sides by 16, and n equals 4. There were no restrictions on this. We had an odd power, so we're all right. Now here we have a rational expression with an equal sign. We don't have to get a common denominator. These are the ones that we all like because all we have to do is to multiply by the denominators until they're gone. My suggestion, start with the biggest one. Let me do this actually first. My excluded value is very simple here. B cannot be 0. B cannot be 0. So like I was saying, I want to kill the biggest denominator first. The reason why I target the biggest one is because a lot of times in killing the biggest one, you also kill the smaller one. And that's the case here as well. Remember, everything gets multiplied times 3b. So essentially what we have is 3b divided by 3b, which of course is 1. We're not going to rewrite it as that form. We're just going to do what we call cancel, that little skill we refer to as canceling. So we're going to cancel out the 3b from the top and the bottom. So what we have left on the left side of the equal signs is just a 1. We also, on the term right here, we can cancel a b from each of these, but there's still a 3 left. So the 3 is going to be multiplied times the 1, so that would be 3. Last term didn't have a denominator to kill anything, so what we're going to simply do here is multiply 2 times 3b, which of course is 6b. Solving for b, so I move the 3 to the other side, which is negative 2. Want to think this through real quick. We're about to get a negative answer. We then divide by 6. Divide by 6. Please don't write 3 there. Take your time, write those out. We sometimes get in a hurry and we'll miss something like that. It is 2 divided by 6, negative 2 actually, divided by 6. Well, that's not 3, that's 1/3. Bigger number was on the bottom, so it better be bigger at the end. So a lot of times we panic. First of all, this is not even a radical, so who cares if it's negative? But even if we have that, we've got to pay attention to our excluded values there. That is not an excluded value, so b equal to negative 1/3 appears to be a correct answer. You can always plug in and see if those answers do jive. All right, this one is a rational expression. And what we need to do is compare the work of the two and combine those and see how long it will take them to do the job. This is, again, the distance equals rate times time formula. Now, it's not distance in this case. This is actually just a job. But if we're talking about how much Ming is going to clean, it says Ming cleans an attic in 11 hours. So what Ming has done is one job, that's our numerator, in 11 hours. So that would be her rate of work. And then Mikhail can clean the same attic in 9 hours. So that is still one job, but this is done in 9 hours. How long would it take them to work if they work together? So we are going to combine their work. So we have one job in 11 hours plus another person doing one job in 9 hours. Well, they're still doing one job when they work together, so that will still be a 1. And the amount of time that it takes them, because that's what we have going on here, the jobs being divided by the amount of time. So we know they're still doing one job, and we just don't know how much time it's going to take them. At this point, we have several options that we can do. Since we do have an equal sign, we could go through and kill the denominators by multiplying 11 and then multiplying by 9. We could get a common denominator, but we're allowed to use our calculator. So what I'm going to do instead, since these are actually both numbers, sometimes we don't think of fractions that way, but these are numbers. I can put these two numbers and just simply add in my calculator. So if you go alpha y equals and you put these two values into your calculator, it's going to tell you that this is 20 over 99 is equal to 1x. And now what I have is a proportion set up on my calculator. So all I've got to do is to cross multiply these terms. So 20 times x would be 20x, And then 99 times 1 is 99. Divide both sides by 20. And then x would equal 4.95. Now let's read the last sentence and make sure we know what we answered. It says, how long will it take them if they work together? So this is the amount of time it would take them if they work together, 4.95 hours. It's always a good idea to go back and look and see that you answered the question that was asked. So in this one, we're asked to simplify and state the excluded values. Well, it's always a good move to just get your excluded values out of the way. So what we have to do, remember, excluded values happen when we divide by 0. If we are doing a radical, that would be something that caused the radicand to become a negative number. So in this case, we have a denominator with variables in it, so we need to make sure that this does not become 0. Negatives are okay on this. We just got to make sure it cannot become 0. You could use the quadratic formula. You can factor. You could graph and see where these cross the x-axis. I'm going to go ahead and factor these. So the factors of 15 that can become 2 would be a positive 5 and a negative 3. And again, these are not solutions. These are kind of the opposite of that. These are values that we can't even use. So obviously, if we can't use them, they cannot be solutions. So we subtract our 5, and we get a value that we cannot use is negative 5. And on the other side, we get a value that cannot be used as 3. So those are our excluded values. Those are out of the way. Go ahead and I'll leave that there. It's not hurting anything. So I've already factored the denominator. So what I'm going to do is I'm going to move this over. Remember when we factored it, it became r plus 5 times r minus 3. And then our numerator is just the r plus 5. Now what you can see is we have r plus 5 being divided by r plus 5. Those are going to cancel. Those are going to cancel. That does not change our excluded value in any way, though. They are still excluded because it would cause us to divide by 0. It would be 0 divided by 0, which is still undefined. So we factor down. Remember, you don't factor down to a 0. You factor down to 1. So we would have 1 over r minus 3. Don't forget, when it comes to checking your answers on these, you can still put y1 in your calculator. All of this stuff. Y2 is this, and they better have matching tables with the exception of the error reading. This is going to have an error reading at negative 5 that this one will not. But other than that, their tables should match identically. All right, so next one we have subtraction. This is probably going to be one of the harder things, is the subtraction. It's a combination of several things. Remember, we do not have an equal sign here, so we don't have the luxury of just simply canceling out the denominator. That would be nice if it were solving, but it is not solving. So what we've got to do is we've got to get a common denominator on this. Now, the common denominator is whatever satisfies both denominators. Well, I like to go over here and write my denominator. One thing that we need is an n minus 5 because of the left side, and we also need an n minus 2 for the right side. So that is our common denominator right there. So we look at that common denominator and we decide what each part needs. Well, this part has the n minus 5, so it needs the n minus 2. Notice I'm putting in parentheses here. We have monomials for our numerators right here, but if we have binomials, we're going to have a distribution problem. So the right side has the n minus 2, it needs the n minus 5, so I'm going to give it to it. And again, this is not canceling a denominator. We're multiplying by n minus 5 on both numerator and denominator, which technically doesn't change anything. We're multiplying times 1. All right? So we've already established what our common denominator is. Write it right here. So let's establish now what our numerator is. And that denominator should not change for us throughout this problem. So we'll keep the numerator in a color green. So we're going to distribute the 3 times n, which would give us 3n. And we have a 3 times negative 2, which is negative 6. Here's a pretty crucial point as well. This is a subtraction problem. It is not just subtracting the first term, it's subtracting the entire thing. So we're going to put the entire right side in a parentheses to make sure that we distribute as we're supposed to. So we are technically distributing a negative 4, but since I set up mine this way, I'm just going to do the 4n, and then I'll distribute the negative sign second. And then 4 times negative 5 is negative 20. So we have that. Might have been a better move to just distribute the negative 4, but as long as it gets distributed, we're okay. So now I'm going to distribute the negative sign into both of those. I'm going to make a big jump all the way down here to the bottom. So we have 3n minus 6 minus 4n plus 20. All of that being divided by, and there's that unchanging denominator, excuse me. I've got to keep in mind as well, I still haven't stated my excluded values. It didn't ask for that, but that's just something we always should have in the back of our mind. So we have some like terms here. I see 3n minus 4n is negative n. And I see negative 6 plus 20. So negative 6 plus 20 would be positive 14. That is not a value that's going to cancel my denominator. So the denominator will be left alone, just like you see there. Now, we could distribute that denominator and see what the answer came out to. If it's a multiple choice test, this is going to be obvious whether you're supposed to do one or the other. It does not matter. The answer is the same, but if you do not see your multiple choice answer, you may want to think about distributing that denominator. That denominator could also be x squared minus 7n plus 10. So that would be another option that you could see. So we've got a division problem here. We also have a denominator issue, so we need to make sure that we state our excluded values. I'm actually going to do that right now. Since this denominator is such an easy one to find, I'm going to take this over here and let myself know, hey, b cannot be 4. b cannot be 4. We have a division problem, so we're going to do a keep, change, flip, keeping the first term the same, changing division to multiplication, and then we're going to flip this expression here. I'm going to go ahead and factor out everything I can before the flip, and then we'll see what happens. Now, if I would have noticed that these twos were the same, I probably wouldn't, because I would be factoring and then canceling anyway, but I can clearly see that these two are different. All right, so let's go ahead and factor where these stand. The factors of 36, that can become 12. Again, at this point, guys, you need to know how to factor. You can factor by graphing. You can factor by, like I'm factoring the binomial. So the factors of 36, that can become 12, would be positive 6 and positive 6. So that's how that term factors. And then the numerator on the other side is going to factor out to b plus 6 and then b minus 4. So we see some values that are about to cancel here. Now we're supposed to keep, change, flip, and state our excluded values, but if the value is going to cancel, that means it's already been stated. So I'm going to go ahead and cancel this b minus 4 over b minus 4. Remember, we can cancel any numerator with any denominator on multiplication and division. So those two are going to cancel one another out. This is just going to make it where I don't have to transfer as much information. So I'm going to rewrite here. So what we have is b plus 6, and I'm going to write this another way, just because. This is b plus 6 squared over 3. You do not have to rewrite that, but we'll just take a look and see what we have. So that's the keep part of keep, change, flip. The change part is the division to multiplication, and then the flip is the entire second term. Well, this actually remember, nothing factors down to 0. This factors down to 1. So when I flip that to the numerator, it's going to be a 1 in the numerator. And now we have a denominator of b plus 6. We'll put it in parentheses just because. Now, we have a new denominator. So when we have a new denominator, or a value in the denominator that was never there, we now have a new excluded value. So we have this new denominator, so we are going to exclude the value that goes with it. Whoops. We're going to exclude the value that goes with it. So the value that comes with that would be b equal to negative 6. All right? So now that we've done that, we can move on. You can actually cancel diagonally on here, or you can do the math straight across. What I'm saying is this: b plus 6 would cancel 1 of the b plus 6 from the numerator there. And this would give us b plus 6 over 3, and we're basically multiplying times 1 over 1, so 1 times 1 stays the same, so we're going to, or 1 times anything stays the same, so this would be our simplified form to the first one. Had you chosen to multiply across, that's okay, before canceling. I'm saying before canceling this b plus 6, let's say you wanted to multiply, that's fine. It would be b plus 6 squared, because that's b plus 6 squared times 1, and then you would have 3 times b plus 6. It does not make sense to distribute this 3, because the 3 is going to cancel the term in the top, or the b plus 6 is going to cancel the term in the top. Regardless of which method you use, if you do it correctly, you're going to end up with the correct answer. And if you're like me and you like to be right, why don't you graph the original question in the y1, graph the supposed solution in y2, and their tables match. I did that, paused it, put those in. My tables match identically, except for an error reading at 4, because remember that 4 canceled out. All right, don't forget you can check your answers by plugging those in. All right, we're going to have to illustrate on this one. It says a farmer plans to build a rectangular pig pen attached to his barn. He purchased 200 feet of wire fencing to enclose 3 sides of a pig pen, with the 4th side being his barn. What is the maximum area? What is the maximum area that he can enclose with his 220 feet of fencing? So here I've constructed what this is going to look like. The red is the barn, and then the green is the 200 feet of fencing. So we do not know how far this side is going to extend from the barn. We do know whatever it is, the opposite side is going to be the exact same thing, because we are building a rectangular pig pen. Now, the third side, opposite of the barn, is going to be whatever we have left. So we have 220 feet of fencing, and we used X amount over here, and we used X amount over here. So we have to take that away from the 220 that we have. So we're going to take away 2 times whatever that X value is. So these are the 3 sides of our barn, of our pig pen, the 4th side being the barn. So we are looking for the area. So remember, this is a rectangular shape, and the area of a rectangle is length times width. Really doesn't matter which one is the length or the width, but we are going to call the length X and the width 220 minus 2x. So now we've got to solve this quadratic equation. So we're going to distribute our x in here. And that's going to leave us with 220x minus 2x squared. So at this point, we have several different options that we could use in order to find our maximum area. You could graph these things and see where the maximum point is. There's a lot of different options you can have here. I'm actually going to go with the axis of symmetry. The axis of symmetry will tell us when we have our maximum area. Remember, what we're looking for is the maximum area, but first we're going to find when we have that maximum area. So the axis of symmetry formula is opposite b over 2a. Well, opposite b is negative 220, all divided by 2 times negative 2. So what we end up with is negative 220 divided by negative 4. So what we learn is that x is equal to 55. Well, what that means is we now no longer have an unknown amount on each of these. It's now known. So I'm going to redraw my shape real quick and just put this over to the side. My rectangular pen, of course, this is not part of it. This is the barn that we see there. But we've now learned is this side over here is now 55. So since it's a rectangle, this side is 55. And then the missing side is going to be to take this equation, 220 minus 2 times x. Well, x is no longer x is now 55. 2 times 55 is 110. So we have 220 minus 110, which is 110. So we have these values. And again, if you would have put this in your graphing calculator, this equation right here or here, you could have just simply looked up or second calculate maximum and found these values, because it would have been the ordered pair 55, and then the output value. Remember, area is length, 110 times 55. So if we have 110 times 55, we have 6,050. So in answer to the question, what is the maximum area? The maximum area we're going to see for this pig pen is going to be 6,050 square feet. All right, I want to remind you of something else that we talked about when we first spoke of this. Remember, the maximum area you're going to get out of a shape is a square. So the best option is to divide your fence into 4 equal parts. And that's going to give your maximum area. But we have a little bit of a caveat on this. So if we were going to divide 220 into 4 equal parts, that would be 55 all around. That's the maximum area you can get with 220 feet of fencing. But if you are given a free side, kind of like we have with the barn here, maybe it says a body of water, whatever the case may be, you always want to take advantage of the free side. So what we do when we have that is we're going to keep the square sides of 55 and 55, but we're going to take that free side, 55 right here, do that in a different color, sorry. We're going to take this free side that we see here, 55, and we're going to move it to join the other one. Since it's a free side, we want to maximize as much of it as we can. So I'm going to move it over here, so we'll have the 55 from the original square, and then we'll have the 55 from the additional part of the square. This will always work when you're trying to maximize the area with a quadrilateral. Circle's your best bet, but since we have a quadrilateral and that's a reasonable shape to make, this is another step you can do to solving these. And you can see I ended up with a rectangle that's 55 by 110, which is what we saw over here as well. So you might want to keep that in mind as well if you see something similar to this. So we're asked to solve a cube root function here. Remember, anytime we're asked to solve a cube root function, we do not reach inside of a radical. That is a big no-no. Big force field surrounding this 2x plus 7. So the first thing we need to do is remove that force field. The force field is a cube root, so the way we get rid of a cube root is we do the inverse, which is to cube. And we cube the left side, then we have to cube the right side. Now the result on the left side is just the cube root being gone. Remember, those numbers inside were protected by the force field so they don't change. On the right side, there was no force field, so 11 to the third power is 1331. And now at this point, we have a linear equation. Now notice I didn't state excluded values because odd roots don't have those. Odd roots don't have excluded values because we can take the square root, or an odd root, excuse me, of a negative number. So we don't have to worry about that. So we're now down to 2x equals 1324. Divide by 2. And we get x equal to 662. Now let me encourage you to put your values in your calculator. Real easy to plug these in. The cube root function is under math, so if you go math and it's the fourth option, type this in. 662, close your parentheses, plus 7, and then get out of the radical. I hit enter, I look at it, it says 11. Now I know with all certainty that my answer is correct. Take that extra time, plug in, see if your answer works. All right, so on the transformations, a little harder to work these out by hand. So my suggestion would be for you to put these in calculator and see what happens. But what I'm going to try to illustrate to you is the parent function, the cube root of x. Well, first of all, the cube root, just like the square root, goes through these 3 points every time. 0, 0, 1, 1, and negative 1, negative 1. All right. Then I keep looking and I look for another number that has a cube root. Well, another number that has a cube root would be 8. The cube root of 8 is 2, so that puts me at that spot. And the cube root of negative 8 gives me negative 2. So what I've drawn for you, hopefully it'll look all right, is the parent function, which is the cube root of x. Looks like that. Now our transformations, think about what these values do. Anything that happens inside of a parentheses is going to be a lateral movement. This is a left to right movement, one of the two. But we also know anything that happens inside of the parentheses has an inverse effect. So a plus 1, that feels like it should move right, but remember we always do the inverse. So all of these 4 points that I have are temporarily, because there's 2 movements, going to be moved to the left 1 unit. So I'm going to move them here, move it here, and then this one actually goes off the screen, but I'm still going to draw it. Okay, and then the second movement happens outside of the parentheses. This is a vertical shift. There are no tricks here, so when I see -2, that means go down 2. So we're going to go down 2 units from that blue point. So the point that was here will now be sitting right there. The point that I move 1 unit left will also go down 2 units, which would put me there. This value here would move down 2 units there. And for some reason I didn't write this one, but I'm going to do it real fast. We'll move this back 1, which would put us there, and then down 2, which will put us in this little range here. And this one is now got to go down 2. Even though it's off the graph, it's close enough for me to do it that way. So now the transformation is complete for this function, and it looks like this. And again, we've got graphing calculators, so check your answers, see that they go through the points. And I'd also suggest look at your ordered pair or your ordered pairs on your table.